Inshallah, in today's class, we are going to continue the higher order differential equations. Questions based on Cauchy's homogeneous equation or Euler-Cauchy's equation. I'll explain in detail. First, you see the questions, solve the questions given here. You see here, this is given as solve the questions. Now, what is here? Watch carefully. You see here, how we can understand. You see, watch carefully. D cube means x cube. With d cube, you will get x cube. D square, x square. Whatever the degree of the differentiation will have, the same will be with x. Then this is called Cauchy's homogeneous equation. D square x square dx d square x square d square x square dx, like this. So this type of questions are called Cauchy's homogeneous equations or Euler's Cauchy's equation. In the examiner will not give this, solve this by Cauchy's linear equation. We must see the question and observe it, and we recognize, we must find that these types of questions are homogeneous equations questions. So there is a method for this. You see here, the first, you see here, d power n x power n, okay, and x power n minus 1 d power x minus 1 x power n minus 2 d power n minus 2. So these are called Cauchy's homogeneous equations or Euler-Cauchy equation. For this, the method is, this is the first. You see here, we have to suppose x equals to e power z. We have to suppose x equals to e power z. And the next one is log. If you apply log x will become z. Log x will become z. So this is the step, x equals to e power z and log x is z. Now this d will changes to from dy by dx to d by dz. Here this is d by dx. But here d means d by dz. Here d means d by dz. Means we are changing the question from d by dx to d by dz. dy by dx to dy by dz. Now watch carefully. These are the formulas. Wherever we find x dy, we suppose this as just dy. Here d means d by dx, but here d means d by dz. So x square d square means d into d minus 1. X cube d cube means d into d minus 1 into d minus 2. And so on. Watch carefully. X d, we must write d. X square d square, we must write d into d minus 1. X cube dv cube, we must write d into d minus 1. So suppose you get x power 4 d power 4 y, then d into d minus 1 d minus 2 d minus 3 into y, and so on. Okay, so let me solve the few questions based on this. These are the 4 examples I wrote. Let me do 1 or 2 questions based on these methods. Okay, let me start. Now let me start the question. See here, first let me write this in the capital D symbol. See here, d square, sorry, x square, no, see here, x square d square, x square d square minus 2xd minus 4 into y equals to x power 4. Now just you see d square x square dx. So this is Cauchy's equation. So how to start? Put like this. Put x equals to e power z. If you apply log x equals to z. This we have to use later, so you know this one. Okay. Now we have the formula x dy equals to, or else you just write x d equals to d, and x square d square equals to d into d minus 1, where d equals to d by dz. Here d equals to d by dz. Now this question will change now. In place of x square d square, you can write d into d minus 1. X square d square is d into d minus 1 minus 2. X into d is d minus 4 into y equals to x. What we have, x is e power z power 4, e power z plus 4. Now let me multiply this. Now we have to continue as same as from the previous questions methods. So you multiply this one. So this will become d into d square minus d into dt minus d minus 2d will be minus 3d minus 4 into y equals to e power 4z, e power 4z. Now auxiliary equation is m square minus 4m minus 3m minus 4 equals to 0. You take, it's easy, if you take from the calcium, no problem, you will get the correct answer. But if you want to factorize, 4 ones are minus plus. So from calcium you will get m equals to minus 1 comma 4. M equals to minus 1 comma 4. Therefore auxiliary equation. Finish, no? Complementary function is y equals to, for different values we know, c1 e power m1. Watch carefully. In place of x you must write z, because now we change to d by dz. So in place of x you must write z plus c2 e power m2z. Now watch carefully. M1 value is minus 4, M2 value is 1. I'm writing like this. C1 e power, I'm writing like this. Z whole power M1. M1 is minus 4 plus C2 e power Z whole power M2. Now M2 is, M2 value is here 1. Why I change it? Because e power Z we are having x. E power Z is x. So this will become C1 x power minus 4 plus C2 x. The power is minus, you bring in the denominator, it will become plus. Therefore now we got yc. Yc equals to c1 by x power 4 plus c2x. Now we got the complementary function. Now for auxiliary you must bring d on the other side. So therefore y equals to 1 divided by d square minus 3d minus 4 into e power 4. Now this is the type 1 method of particular integrals. In particular integrals we already seen that here we have to keep d. If we, what is the method for this? D equals to e. We have done this e power x questions type 1 method. In place of a we are having 4, so d equals to 4. Now you write in place of d as 4, in place of the e power. Okay, so let me change this. Therefore particular integral is yp equals to 1 divided by d. We know d is 4 square. 4 square minus 3 into 4 minus 4. But you see here, if you do it, it will be 4 square 16 minus 16 is 0. But 16 minus 16 is 0 means 0. 1 by 0 is not defined. So we have to change the method. What is the method? Multiply numerator by x, but here by z. Multiply numerator by z and differentiate denominator with respect to d. This is the method we already discussed. Okay, so yp equals to multiply numerator with z and differentiate denominator with respect to d. D square will be 2d minus d is 1 into 3 is 3 into e power 4z. Now we can keep d equals to 4. If you keep d equals to 4, 2 4s are 8. 2 4s are 8. 8 minus 3 5. So we can write z by 5. Sorry, z by 5. Z by 5. We can write like this: e power z whole power 4. Now z in the above we have already noted this is as z value is log x. E power x, e power z is, we are having e power z as x, so this will be x power 4 by 5. Now therefore complete solution is y equals to yc plus yp. Y equals to yc, we got already. Yc value is c1 by x power 4 plus c2x plus yp. Yp is x power 4 log x divided by 5. Let me do one more question to practice this. Now see the next question, same type method. I wrote already few steps. You see here, dx cube, d cube short symbol, 2x square capital D square plus 2 taken y common, x plus 1 by x. Now what is the method? Put x equals to e power z so that log x equals to z. Now we are having x square d square, its formula is d into d minus 1 into y. X cube d cube is d into d minus 1 d minus 2 into, okay, we are taking y common. Let me write this also, where d equals to d by dx. Now the question will change now. This d x cube d cube will become d into d minus 1 d minus 2. X 2 into x squared is square is this plus 2 into y equals to x here. So value of x is e power z plus 1 by x means 1 by e power x. Now let me multiply this one. See here, if you multiply d into d, sorry, d into d square into d cube, d into minus 2d minus 1d minus 3d minus 3d into d minus 3d square minus into minus into plus 1 2s are 2 2 into d 2 plus 2d square minus 2d plus 2d. Now you get cancel this plus 2d minus 2d. What is left here? D cube minus 3d square plus 2d square minus d square plus 2. Now auxiliary equation is m cube minus m square plus 2 equals to 0. On solving this, you will get the values from calcium. Take calcium. No need to do just to take from the calcium. Okay. Now this is like the form alpha plus or minus I beta. So therefore complementary function is e power alpha x into c1 cos beta x plus c2 sine beta x. In place of x must write z. And also one more is there, no? So we continue this c1 c2, this should be c3 e power m1 z. Now this is minus, okay, here watch here, equals to e power alpha is 1 e power z, this will be okay. Now c1 cos beta, beta is 1 here, 1 into z is z, but z is log x plus c2 sine z is log x plus c3 e power 1, this is 1 into z, z e power 1 into z, z. But e power z we are having in the e power z is nothing but x. So we got this complementary function equals to, let me take common e power x z, e power z is x. So if you take x common, c1 cos of log x plus c2 sine of log x, sine of log x plus c. So now we got complementary function for particular. So this is the complementary function. Now for particular, let me bring e power z, e power. So for particular, we bring d on the other side. So I'm writing like this: 1 divided by d cube minus d square plus 2 into e power z plus e power minus z. Now you separate this one, you separate this one. So you will get like this: yp equals to 1 divided by d cube minus d square plus 2 into e power z plus 1 divided by d cube minus d square plus 2 into e power minus z. Now for what is the method for e power ax? We have to put in place of d a. In place of d we have to put a. See here. Here what is e power az? A is 1 here. So in place of d we have to keep 1. Here we have to keep in place of d minus 1. Now continue this. If you put d equals to 1, plus 1 minus will get cancelled. What is left here? 1 by 2 e power z plus. If you put minus 1 here, this will become minus 1 minus 1 minus 2 plus 2 will get cancelled. So this is 1 by 0 not defined. So what is the method? Multiply numerator by x. Here multiply numerator by z. Multiply numerator by x means here z, and differentiate denominator with respect to z d, sorry. So dq will become 3d square minus 2d, and constant is 0 e power minus z. Now again if you keep in place of d minus 1, this will become minus square plus 3 minus 1 plus 2 5. So and what is the value of e power z x? In the previous we already knew e power z is x, so yp equals to e power x is z by 2 plus what we are having here is z. What is the value of z? Log x. Log x divided by, this is 3 minus 1 is plus 2 5. This is x power minus 1. You can write like this: 1 by e power z. E power z is x, so we'll get x in the denominator. So we got yp. Therefore we know you substitute this y equals to yc plus yp. Okay. Now see here there is slight change now. The same, now we are going to learn about the Legendre's linear equation. Legendre's linear equation. So what is here? Just change, little change. In place of x power n, we have some coefficient is there with x. A plus bx power, a plus bx power n minus 1, ax plus b power n minus 2, n minus 2. So there is a slight change here, and the substitution is also little changes. You put a plus bx equals to e power z. Put a plus bx equals to e power z. Log of a plus bx will become z. And the change here you see here, a plus bx dy by dx will be b into dy. This is b. B is the coefficient of x, b into dy. And whole square d square y by dx square means b square d into d minus 1. B square. And whole cube means b cube d into d minus 1 d minus 2 into y. Revise this one's formulas. Let me do one question based on this formula. Now you see, let me start this question. You see here we are having with x coefficient. 3x plus 2 whole square d square y by dx square plus 3 into 3x plus 2 dy by dx plus 2. Let me show this in capital D form. See here 3x plus 2 square d square plus 3 into 3x plus 2 into d minus 36 into y equals to 3x square plus 4x plus 1. Now next step, what is the method we are having? Put 3x plus 2 equals to e power z. Therefore, log of 3x plus 2 equals to, if you apply log here, this will become z. So we got the value of z, we got, and 3x plus 2 is, we suppose this as e power z. Now the next step, this is the formula we are having. 3x plus 2 into dy by dx equals to, here this is a into dy, a into dy. In this, what is the value of a here? Here we are having a is the coefficient of 3, coefficient of x, 3 into d. Now next step is 3x plus 2 whole square d square y by dx square is a square d into d minus 1 into y, d into d minus 1. So this will become a square means 3 square, 3 square is 9 into d minus 1 into y. So let me change this one. This value we have to substitute this one, 9 into d minus 1. Let me take y common, this is finished, plus 3 into, again this value is 3 dy. Okay, let me take y common, minus 36 into y equals to 3 into x square. Now the value of x from this, sorry, from this you bring the value of x, this, see here, if you bring 2 here, I'm writing here 3x equals to 3 e power z minus 2. If you bring 3 there, it will be divided, so x will be 3 power z minus 2 by 3. So 3 into x square, 3 into x square means e power z minus 2 divided by 3 whole square, 3x square, plus 4 into x is 3 power z minus 2 by 3 plus 1 plus 1. So let me multiply this one. Let me take 9 common. 9, 3 is a 9, 9. If you take 9 common here, what will be left? It is left with d into d square, d into minus 1 minus d plus d will cancel. 9 fours are minus 4. Okay, equals to 3 into, we expand this a minus b whole square, a square means e power z whole square, e power 2z minus 2ab, 2 2s of 4 e power z plus b square, 2 square 4 by 3 square 9, plus you multiply this 4 e power z minus 4 2s are 8 by 3 plus 1, 3 1s are 3 3s are. Okay, now let me take LCM here, let me take LCM, so into y we are having, okay, 9 into d square minus 4 equals, if you take 3 LCM, what we get? E power 2z minus 4 e power z plus 4 plus 4 e power z minus 8 plus 3 1s are 3 plus 3 1s are 3. This minus and plus will get cancelled. We bring this 9 also there, into y, sorry, d square minus 4 into y equals to e power 2z, e power 2z, 4 plus 3 is 7, 4 plus 3 is 7, 7 minus 8 is minus 1, and divided by, you bring this 9 here, so it will be divided by 9, divided by 9. Sorry, here you will get 9 3s are 27, so divided by 27. Now auxiliary equation, here you keep m square minus 4 equals to 0, m square equals to 4, so m equals to plus or minus root 4, that is m equals to plus or minus 2. Therefore complementary function is c1 e power m1, in place of x you must write z, plus c2 e power m2 z. See here I'm writing like this, c1 I'm writing like this, e power z, e power z whole power m1, whole power m1. M1 value suppose we take 2 plus c1 e power z whole power m2. Now in the above board, the value of e power z is 3x plus 2. So we write like this: 3x plus 2 whole square plus c1 into 3x plus 2 whole power minus 2. We bring this down, therefore we get the complementary function as c1 into c1 into 3x plus 2 whole square plus c1 by 3x plus 2 whole square. Now we got the complementary function. Now let me find the particular integral. For particular integral, let me note this. For particular integral, we have to bring d on the other side. So let me bring d on the other side. Let me bring d on the other side. See here. Let me continue from here. See what's good. So if we bring d on the other side, what will happen? Yp. You see here, yp equals to 1 divided by d square minus 4 into e power 2z minus 1, e power 2z minus 1. We are having 27. Now let me write 27 here. We can take out 27 because it's constant. So yp equals to, now you separate this two. You separate this two. You see here I'm writing here yp equals to 1 by 27 into d square minus 4 into e power 2z, this one, minus 1 by 27 into d square minus 4 into 1. Now see here, what is the method we are having in for e power ax? For e power ax, we are having the method a d equals to a, d equals to 2. But if you keep 2 here, 2 square 4, 4 minus 4 becomes 0. So if we getting 1 by 0 not defined, 1 by 0 not defined, therefore what is the method? Multiply numerator by x and differentiate denominator with respect to d. So multiply numerator with a z because we are having z now. Z divided by 27 into. Now if you differentiate this one, this will become 2d, constant is 0, into e power 2z minus. We already learned that if we get constant, we write this as e power 0x. E power 0x. So if we substitute in place of d a, so d equals to a equals to 0. That means if we keep here 0, this will become 0. So minus into minus, this will become plus 1 by 4 7s are 28, carry 2, 4 to 10. So one more step is left. Now we substitute here d equals to a. So d equals to 2, 2 2s are 4, 4 into 27 will be 108. Let me take 108 common. So yp equals to, if we take 1 by 108 common, what is left here? It is left with z into e power 2z plus 1. So we can change out z value we are having as log of 3x plus 2. See here last step. Okay, let me, you can write by yourself. You see here yp equals to 1 by 108 into z. The value of z in the starting, we have noted this as log of 3x plus 2 into, you can write like this, e power z whole square. E power z is 3x plus 2. So 3x plus 2 whole square plus 1. So lastly you write by yourself y equals to, the complete solution is yc plus yp. Yc plus yp. So in this class we have learned two methods. Same type, little change in the methods. So in the next class inshallah we are going to continue the next topics inshallah. So you practice these two methods, Legender's homogeneous equations and Cauchy's homogeneous linear equations. Okay, inshallah in the next class we'll continue with the next types of questions.